Consider the void. Not the gentle dark of a moonless night, nor the deep shadow between stars you can see. Consider instead the ultimate negation, a domain so profoundly vacant it redefines the very concept of emptiness. To speak of it is to speak of a condition, not a location, a state of being so removed from the bustling marketplace of existence that it exists as a monument to absence. You are an astronaut, untethered, adrift in a sea of nothingness, so vast it beggars the imagination. You are tumbling, a solitary, fragile mote of consciousness, through the greatest stretch of cold darkness in the known universe. This is not a place of mere quiet or solitude. It is a realm where the cosmic tide has fully receded, leaving behind a basin of near-perfect nothingness. A place without stars, without planets, without the faint, swirling pinwheels of galaxies. A place where you would not encounter another soul, would not glimpse another island of light for distances spanning hundreds of millions of light years. This is not a metaphor. It is a geographic reality in the cosmos, a cavern in the architecture of existence. This place has a name, the Baute's Void, or, as it has been evocatively termed, the Great Nothing. And unless you, our lost astronaut, can somehow find your way back to the faint, dwindling speck of your ship, you will be condemned to drift through the perplexing, unrelenting dark of this mysterious expanse for time periods that dwarf human history. That is to say, your frozen, desiccated body, a museum of what once was life, would traverse this incomprehensible ocean for billions of years, because there is no one out here to retrieve you. No rescue mission could ever be mounted. You are beyond lost. You are in the void. This concept of emptiness is a shadow that has followed humanity since the first moment we looked upward and wondered. The ancient philosophers of Greece debated the kenon, the void. Was it possible? Could there be a space where nothing, not even air, resided? Democritus, with his atomic theory, argued for the void as the necessary stage upon which atoms moved. Without it, he reasoned, motion would be impossible, for there would be no place for things to go. Aristotle, in contrast, railed against the idea, proclaiming that nature abhors a vacuum. For nearly 2 millennia, this Aristotelian view held sway, a philosophical and physical principle that seemed intuitively correct. The world was full, a plenum. The very heavens were imagined as a series of crystalline spheres, nested and perfect, with no room for emptiness between them. It was a comforting, enclosed cosmology. But the universe is under no obligation to conform to our intuitions. The invention of the pump in the 17th century and the struggle to make it lift water more than about 10 meters provided the first physical clue. Evangelista Torricelli, a student of Galileo, suspected it was not a failure of the pump but the weight of the air itself, pushing down on the water, that set this limit. In 1644, he filled a glass tube with mercury, sealed one end, and inverted it into a dish. The mercury column dropped, but only part way, leaving an empty space at the sealed top. He had created a sustained vacuum, a void in a tube. The weight of the atmosphere was balancing the column of mercury. Aristotle was wrong. Nature did not abhor a vacuum, it merely succumbed to pressure. The void was possible here on Earth. This was the first crack in the dam of cosmic plenitude. It was a small void, a few inches long, but its implications were boundless. If a vacuum could exist in a Florentine laboratory what might exist in the heavens, freed from the clinging grasp of an atmosphere. Centuries of astronomical observation seemed to confirm a star-filled plenum. The telescope revealed more stars, not less. The Milky Way resolved into a countless multitude. The distant nebulae, once fuzzy patches, were in turn resolved into other galaxies, each with its own billions of suns. The universe appeared not just full, but overcrowded, a dizzying excess of light and matter. It was only when we learned to see in 3 dimensions, to measure not just the direction to a galaxy, but its distance, that the true architecture began to reveal itself. And in that revelation, we found that the ancient intuition of the atomists was, on a scale they could never have dreamed of, profoundly correct. The universe is mostly void. The stage is not just present. It is the dominant actor, the vast and silent backdrop that makes the fleeting play of matter possible. What is truly fascinating, and perhaps unnerving, about this particular chasm in space is that you have been staring directly at it, unknowingly, for your entire life. Look up into the northern sky on a clear, dark night. Find the familiar ladle of the Big Dipper, that asterism which has guided travelers and storytellers for millennia. Its 7 bright stars are our local neighbors, none more than 100 light-years away. And then trace an arc, as the old mnemonic goes, arc to Arcturus, that brilliant orange-red giant, the 4th brightest beacon in our celestial sphere. Arcturus is an ancient star, a visitor from an earlier epoch of galactic formation, now passing through our suburban spiral arm. It burns with the calm, steady light of a hydrogen-fusing giant, 37 light-years away. Stretch your finger along that imaginary line from the handle of the Dipper to Arcturus. Now continue just a little further into a patch of sky that seems unremarkable, a blank canvas sprinkled with a few faint, unrelated stars that lie in the foreground of our own galaxy. Right there, in that apparent nothingness between the constellations, lies a window, a tunnel, a direction pointing not to a star, but to a profound lack of them. You are staring directly into the heart of the void, the Boötis void, residing within the bounds of the Boötis constellation, the herdsman. From our vantage point, drowned in the light of our own galaxy's disk, you can barely perceive its presence. It is a subtle, statistical ghost in the data of astronomers, a silent scream in the cosmic static. But it is there, a yawning gulf. And while you may think you never want to end up there, in a grand, metaphorical sense, that is precisely where you are going. We all are. For the universe is expanding, and the vast, empty spaces between things are growing ever larger, ever darker. The void is not just a place out there, it is the inevitable destination of all things, as islands of matter are pulled apart by the relentless stretching of space-time itself. The galaxies are not flying apart through space. The space between them is itself swelling, a rising dough in which the raisins of matter grow ever more isolated. The void is the future. It is the fate of all light, all structure, all memory. To contemplate the Boötis void is to take a journey to the end of time, today. What, then, would it truly be like to fall into this incomprehensible ocean of darkness? The experience does not begin at its edge. It begins with a journey of such staggering duration that it melts the very meaning of time. To even approach the Boötis void requires a voyage across an abyss of time as much as space. It is situated approximately 700 million light-years from our pale blue dot. That number, 700 million, is a quiet seismic shock. It does not convey immediacy. It must be unpacked, felt in the bones of history. The Andromeda Galaxy, our closest major galactic neighbor, the great spiral that will one day merge with our own Milky Way in a slow, majestic dance, lies a mere 2.5 million light-years away. The Boötes void is 280 times farther. To travel a single light-year is to voyage across nearly 10 trillion kilometers, a distance light itself. The universe's ultimate speedster takes a full year to traverse. So even if you could harness the impossible, if you could ride a beam of light becoming massless, timeless, the journey to the void would consume 700 million years. Contemplate that span. That is roughly the entire evolutionary journey of complex animal life on Earth. It is the span from the first simple multicellular organisms clinging to ancient seafloors, through the age of fish, the conquest of land by amphibians and reptiles, the reign of the dinosaurs, their catastrophic demise, the rise of mammals, the slow blossoming of intelligence, and the entire fleeting pageant of human history, from the first toolmakers to the builders of civilizations, to you sitting here now. All of that compressed history, that epic saga of life and death and struggle and wonder, would be but the duration of your one-way trip. The void does not merely exist far away, it exists in a different epoch. To reach it at light speed is to commit to a future so distant, our sun will have long since expired, our galaxy irrevocably altered. The light we see from the void's direction tonight left its last outlying galaxies 700 million years ago. We are not seeing the void as it is, but as it was when the first simple animals were stirring in Earth's oceans. We are looking into a fossil of absence, a prehistoric cavity. Yet, light speed is a forbidden fantasy for anything with mass. It is a cosmic speed limit enforced by the immutable geometry of spacetime, as expressed in Einstein's theory of special relativity. As an object with mass accelerates, its energy increases, but that energy manifests not just as speed, but as additional mass. To approach the speed of light would require infinite energy. It is a barrier as fundamental as the impossibility of turning lead into gold was to the alchemists. Our current technology renders the journey not merely difficult, but cosmologically absurd. Consider our fastest human-made object, the Parker Solar Probe, which kisses the Sun's corona at a breathtaking 700,000 kilometers per hour. This velocity, while monumental in human terms, it could traverse the United States from coast to coast in under 30 seconds, represents a mere 0.05% of the speed of light. At this pace, a journey to the Boötes void would not take millions or billions of years, but over 1 trillion years. A trillion, a 1 followed by 12 zeros, this number exceeds the current age of the universe by nearly 100-fold. It is a timescale on which stars themselves will have begun to wink out, their fuel exhausted, leaving the cosmos a colder, darker place. The very concept of a mission, of a purpose, evaporates over such an interval. It is a timescale of cosmic decay, not of exploration. And of course, the Parker Solar Probe is a stout-hearted but minimalist machine. No life support, no seats, no windows. It is a dedicated instrument, not a vessel. It is a testament to our curiosity, but also a measure of our profound confinement. So we must, for the sake of this contemplation, engage in a profound act of imagination, a what-if of the highest order. Let us imagine a vessel, a ship born of physics we do not yet comprehend, a technology that sidesteps the tyranny of relativity, perhaps by manipulating the fabric of space-time itself, as in the hypothetical concept of an Alcubierre warp drive, creating a bubble of contracted space ahead and expanded space behind. Or perhaps it is a generational ship, a world unto itself, where centuries pass as gardens are tended and stories are told, and the original mission is a myth to the descendants who finally arrive. You climb aboard. The airlock seals, Earth falls away, a blue-green marble against the velvet black. The psychological severance is immediate. You are leaving not just a place, but an era. Every face you have ever known, every tree you have ever touched, will be dust long before your journey is a fraction complete. You are a volunteer ghost, departing the land of the living for a destination that is the antithesis of life. But leaving Earth is a trivial first step. Leaving the solar system is an epic in itself. You cannot simply aim for the stars and fire the engines. You are a prisoner of gravity, a subject in the sun's court. To break free, you must achieve escape velocity, a speed sufficient to overcome the gravitational embrace of our star. Earth itself orbits at a stately 30 kilometers per second, or about 18.6 miles per second. To leave the sun's dominion from Earth's orbit, your ship must achieve a speed of approximately 42 kilometers per second, or about 26 miles per second, relative to the sun. And your path would not be a straight line piercing the dark. It would be a spiral, a graceful, widening arc. You would slingshot around the sun, each orbit carrying you farther afield, using the star's own gravity as a catapult. This is the ballet of orbital mechanics, a dance of vectors and velocities first understood by Johannes Kepler and given physical cause by Isaac Newton's law of universal gravitation. In our hypothetical ship, this is a mere formality. You have the power. You watch as the planets recede. Mars, a rust-colored dot. Jupiter, its stormy bands shrinking to a faint striped marble. Saturn, its rings becoming a thin ethereal line of frozen dust and ice. The sun diminishes from a blazing disk to merely the brightest star in the sky, though still potent, still the center of your celestial navigation. You cross the heliopause, that turbulent boundary where the sun's solar wind, a stream of charged particles, finally meets the pressure of the interstellar medium. Here, the Voyager probes have gone before, beaming back data of magnetic field shifts and cosmic ray increases. You have left the sphere of our sun's immediate influence. You are in interstellar space. The sunlight that now reaches your ship is 8 minutes and 20 seconds old, but it is no longer the dominant light. Constellations have already begun their slow glacial distortion as your motion relative to the nearby stars creates a new parallax, a shifting of the heavens that would be imperceptible over a human lifetime, but is now a visible crawl across your viewports. And now, as you push onward, a subtle, profound change begins to occur in the vista around you. The sky from the inner solar system is a rich tapestry. The Milky Way arches overhead, a river of crushed diamonds, of millions of unresolved stars, a band of soft luminescence punctuated by dark lanes of interstellar dust, the coal sacks and rifts that are not emptiness but obscurity. But as you travel farther from our galactic disk, that river narrows. The stars, which from Earth seem infinite and evenly scattered, reveal their true distribution. They are concentrated in a relatively thin plane, a disk about 100,000 light-years across, but only about 1,000 light-years thick. Leaving the galaxy is like departing a brilliantly lit city for the open countryside, watching the glow on the horizon shrink and fragment into individual, isolated farmsteads. The foreground stars of our spiral arm thin out. The distant backdrop of the Milky Way's bulge and opposite spiral arm fades. Eventually, you cross the gravitational threshold, the point where the Milky Way's pull is no longer dominant over the subtle tugs of other galaxies. You have left your stellar city entirely. The familiar constellations, patterns drawn from stars, all within a few hundred light-years, dissolve into meaninglessness. The sky is now dominated not by points of light, but by faint, fuzzy smudges. These are galaxies. Island universes, each containing hundreds of billions of stars of their own. For a time, your journey is framed by these distant archipelagos: Andromeda, a tilted spiral of soft glow; the Pinwheel Galaxy, face-on and majestic; the Sombrero Galaxy, with its dark dust lane like a cosmic brim, all glowing with the soft integrated light of their countless suns. This is the local universe, a neighborhood of a few dozen galaxies bound by gravity into the local group, itself part of the larger Virgo supercluster. But your course is set for the void. And as you persevere over millennia and then millions of years at near-light speed, even these galaxies begin to thin. You pass the last outlying clusters, the final gravitationally bound groups of galaxies that cling to the edges of the cosmic web. You might pass through something like the Ursa Major cluster, a collection of galaxies in the same region of sky as the Big Dipper, that familiar asterism now lost to an unimaginable distance behind you, its stars redshifted into invisibility. Beyond this point, the celestial geography changes decisively. Ahead lies not a scattering of lights, but an increasing emptiness. The backdrop of space, which even in the deepest intergalactic space is peppered with the faint ghosts of ultra-distant galaxies, begins to simplify. The dots vanish. The smudges fade. The canvas becomes preternaturally blank. You are approaching the shores of the Boötis Void. It announces itself not by a wall, but by a deepening quiet, a visual hush that settles over the universe. The last few galaxies you pass are isolated, forlorn, like solitary trees on a vast, empty plain. They are the outposts of the cosmic web, the final sentinels before the desert. Yet here lies one of the most mind-bending realities of this structure. Arriving at its perceived edge is not like approaching the shore of an ocean. There is no clear boundary, no line where something becomes nothing. The distribution of galaxies simply becomes sparser and sparser, a gradient of diminishing returns, a statistical fade-out. Astronomers define a void's edge by an isodensity contour, a mathematical surface where the density of galaxies falls to, say, 10% of the cosmic average. But in reality, you cross no such line. You sail from a region of few galaxies into a region of fewer, and then fewer still, until you realize you have been within it for millions of light years already. It is a transition as gradual as sailing from coastal waters into the open ocean, where the last sight of land slips below the horizon and you are surrounded only by water and sky. But here, the water is the void, and the sky is also the void. There is no horizon, and once you are unequivocally within its grasp, your journey is far from over. For the Boötis Void is not a small pocket of emptiness. It is a sphere of staggering scale, approximately 330 million light-years in diameter. To grasp this, consider that our entire local group of galaxies, including the Milky Way and Andromeda, is about 10 million light-years across. This void could contain over 30,000 such groups lined up side by side. Traveling at the speed of light, it would take you 165 million years to voyage from one edge to the dead center. If we dared to translate that into terrestrial units, the distance to the center is about 1.5 quadrillion kilometers, or roughly 1 quadrillion miles. That is a 1 followed by 15 zeros in kilometers, a 1 followed by 12 zeros in miles. It is a number so large it becomes an abstraction, a monument to scale. This is why it earns its title, the Great Nothing. It is not an absence of things, it is an empire of absence. Within its volume, you could place the entire Virgo supercluster, our local metropolis of thousands of galaxies, and it would rattle around like a single pebble in a cathedral. Let us say, against all odds and physics, you decide to disembark. You bring your ship to a relative halt at the precise geometric center of this sphere of nothing. You slip out of the airlock. What surrounds you? It is not like falling into a pit, for there is no gravity well to pull you. It is not like floating in Earth orbit, where the planet fills half your view, a breathtaking panorama of swirling clouds and continental shapes. It is pure, unadulterated emptiness. There is virtually no matter here, perhaps a few hydrogen atoms per cubic meter compared to the billions per cubic meter in our galactic neighborhood, and the tens of quintillions per cubic meter in the air you breathe. There is hardly any light. Your eyes, those remarkable biological instruments evolved to interpret the photons of our sun, sensitive across a narrow band of wavelengths we call visible light, would be rendered almost useless. In every direction you look, with your naked eye, you would see not a single point of light, no stars, no galaxies. The closest island of stars is over 10 million light-years away. At that distance, even a brilliant spiral galaxy like our own would have an apparent magnitude far below the threshold of human visual perception, which is around magnitude 6 under ideal conditions. It would be a faint whisper of photons, detectable only by the most sensitive telescopes accumulating light for hours, not by the rods and cones in your retina. To you, the universe would appear as a perfect, unbroken pitch black. It is a blackness deeper than any cave, more absolute than any sensory deprivation tank on Earth. In those environments, your body still feels the pressure of water or the confines of a chamber. Your ears detect the muffled silence of your own physiology, the rush of blood, the beat of your heart. Here, there is no medium. There is a vacuum so complete that sound is not merely absent, it is an impossibility. There is nothing to carry a vibration. Shouting would produce no wave, only the silent, frantic vibration of your own vocal cords within your helmet. And it is cold, unimaginably cold. The temperature of the cosmic microwave background radiation, the faded afterglow of the Big Bang, is about 2.7 degrees above absolute zero, or minus 270.45 degrees Celsius, minus 454.81 degrees Fahrenheit. This is the baseline temperature of the universe, the remnant heat from its fiery birth, now stretched and cooled to a uniform whisper of microwaves bathing all of space. In the void, with no nearby stars to provide warmth, this is the temperature that pervades. Your spacesuit, a marvel of engineering, would be your only barrier against this ultimate chill, a tiny pocket of borrowed heat in an infinite freezer. The heat from your body would radiate away into the void, slowly but inexorably, with nothing radiating back. You would be a 37 degrees Celsius anomaly in a 2.7 degree Kelvin universe, a fleeting spark of thermodynamic rebellion. How did humanity, cloistered on our tiny world, ever discover something that is, by its very nature, defined by what is not there? The story begins not with seeing the void, but with noticing a strange pattern in what we could see. It is a story of mapping the invisible. In the 1970s and early 1980s, astronomers like Robert Kirshner and his colleagues were engaged in a monumental task, building a three-dimensional map of the universe. They were not just cataloging stars, but galaxies, measuring their distances using the redshift of their light, the stretching of their light waves toward the red end of the spectrum, as they recede from us due to the universe's expansion, a phenomenon first observed by Vesto Slipher and later explained by Edwin Hubble. Redshift becomes a cosmic odometer. By measuring how much a galaxy's light is stretched, astronomers can calculate its recessional velocity and, using Hubble's law, its distance. As they surveyed a region in the constellation of Bootes, they found a startling paucity. In a sphere of sky that, based on the average density of galaxies, should have contained thousands of bright galaxies, they found only a handful. It was a monstrous, spherical gap in the cosmic distribution, a hole in the Swiss cheese of the cosmos. The discovery, published in 1981, was met with a mixture of awe and skepticism. Empty space in the middle of space, it seemed a paradox, an optical illusion perhaps, or a region obscured by galactic dust in our own Milky Way. But the data was clear. They had meticulously subtracted foreground objects and corrected for obscuration. The emptiness was real. They had stumbled upon a void. They named it, simply, the Bootes void. It was initially estimated to be about 250 million light-years across, a figure later revised upward as surveys improved. It was the first of the giant voids to be identified, and it remains one of the largest known. This discovery was a pivotal piece of evidence leading to our modern understanding of the universe's large-scale structure. When you look up at the night sky, it is easy to imagine stars scattered uniformly, like dust. But the reality is far more structured and far more beautiful. The universe is arranged into a vast cosmic web. Picture the froth on a cappuccino or the delicate filaments of a spider's web illuminated by dew, or the neural connections of a gargantuan brain. On the largest scales, matter is not evenly distributed. It is concentrated into immense thread-like structures called filaments. These filaments, composed of galaxy clusters and superclusters, stretch for hundreds of millions of light-years. They intersect at dense nodes, where many galaxies crowd together in massive clusters bound by gravity. And between these filaments and nodes are the voids, the great bubbles in the cosmic foam. This is not a metaphor for tiny soap bubbles, but for the foam in a raging ocean, where the water and air create vast, interconnected, empty spaces within a turbulent structure. The universe is that foam, with the galaxies and clusters being the thin walls of the bubbles and the voids being the overwhelming volume within. The Sloan Digital Sky Survey and other massive cartographic projects have since mapped this web in exquisite detail, revealing a universe that is lumpy, filamentary, and mostly empty. Scientists now estimate that voids constitute about 80% of the volume of the observable universe. Emptiness, it turns out, is the default state of the cosmos. The stars, the galaxies, the planets, and we ourselves are the rare exceptions, the delicate froth on a dark, boundless sea. We do not live in a universe of islands in an ocean. We live in an ocean of nothingness, dotted with rare, fragile archipelagos of something. Why does the universe have this frothy, filamentary structure? The answer lies with the most familiar and yet most mysterious of forces: gravity. Since the universe burst into existence in the cataclysm we call the Big Bang, some 13.8 billion years ago, gravity has been the great sculptor. It is the force of attraction between all masses, the curvature in space-time described by Einstein's general relativity. In the earliest moments, the universe was almost perfectly smooth, a seething, hot plasma of particles and radiation. Thanks to quantum mechanics, the rules governing the subatomic realm, there were tiny quantum fluctuations, microscopic ripples in the fabric of space-time itself, imprinted upon that primordial plasma in the first fractions of a second. These fluctuations were random, tiny variations in density. Some regions had a few more particles, others a few less. As the universe expanded and cooled over hundreds of thousands of years, these tiny seeds were frozen into place when matter and radiation decoupled, an event we see as the cosmic microwave background. The slight temperature variations in that background radiation are the baby pictures of these density fluctuations. And then gravity began to work. It is a patient, relentless force. Regions with a tiny bit more mass exerted a slightly stronger gravitational pull, drawing in more matter from their surroundings. Over hundreds of millions, then billions of years, this process of gravitational amplification snowballed. The denser regions became denser, forming the first stars and galaxies. The emptier regions were drained further as matter flowed toward the denser areas. Matter flowed from the voids into the filaments and nodes, like water draining from high ground into river valleys and lakes. The voids are the high ground that was left dry. They are the regions that lost the cosmic tug-of-war. Their emptiness is not primordial, it is evolved. It is the result of 13.8 billion years of gravitational redistribution, leaving behind these vast echoing caverns. The Botez void is simply the largest and most extreme example we have yet found, a superlative emptiness born from the same processes that crafted the galaxy clusters. We find so luminous and inviting. It is a negative monument to gravity's power, a cathedral built not by accumulation but by evacuation. So, returning to you, our astronaut, floating at the heart of this superlative emptiness, what is the sensory and psychological reality? A void is not an object, it is a condition. If you were to slip from your ship, you would simply float in microgravity as you would anywhere in deep space. But here, the experience would be qualitatively different. In orbit around Earth, you have a powerful reference point, the planet itself sweeping majestically below you, a whirl of dynamic color and life. You have a sense of up and down, of motion, of orbital period. Near a star, you have a source of light and heat, a directional beacon that defines your universe. In the Botez void, you have none of that. Every direction is identical. A perfect, unrelieved black, without a fixed point of light. Your vestibular system, your internal sense of balance and motion, located in your inner ear, would have nothing to latch onto. It relies on visual cues and the pull of gravity on tiny otoliths. In zero gravity, with no visual reference, it becomes profoundly confused. You would quickly lose the ability to tell if you were spinning, tumbling, or motionless. It would feel like an endless, directionless freefall. If your ship's systems failed, plunging you into absolute darkness, the experience would transcend disorientation. It would be the utter annihilation of spatial context. You would be a consciousness adrift in a sensory vacuum. It is the abyss in the most literal and philosophical sense, the quintessential chasm of nature. This sensory deprivation would likely lead to profound psychological effects. Hallucinations, as the brain, starved of input, begins to generate its own intense anxiety, a disintegration of the sense of self. Time itself would lose all meaning. Without the rise and set of a sun, without the circadian rhythms ingrained in your biology, your perception of time would distort and potentially collapse. Minutes could feel like hours. Hours could vanish in an instant. You would be untethered from the fundamental rhythms that have shaped life on Earth for billions of years. Perhaps, if your spacesuit were equipped with hypersensitive instruments tuned to wavelengths far beyond the visible, a faint ghost of structure might be perceived. Because, despite its terrifying name, the Great Nothing is not completely empty. Subsequent, deeper surveys with more powerful telescopes have revealed that the void is home to perhaps 60 galaxies. This number, in a volume that could comfortably hold tens of thousands of galaxies, only underscores the emptiness. 60 galaxies in that space is akin to scattering 60 grains of sand across the entire continent of North America. They are there, but their presence is statistical, not perceptual. Most of these lonely galaxies are thought to be huddled along a single tenuous filament that snakes through the void's interior, a remnant thread of the cosmic web that failed to fully evacuate, a cosmic river that dwindled to a stream and then to isolated ponds. These galaxies are likely strange places, starved of intergalactic material to fuel new star formation. They may be red and dead, aging stellar populations fading in isolation. Or they might be experiencing a burst of frantic final star formation as their last gas reservoirs collapse. Your chances of ever seeing one of these galaxies with your naked eye, even if you knew precisely where to look, are zero. They are too faint, too distant from one another. So, to your senses, the void is absolute, utter silence. For sound cannot travel, pure vacuum with pressure effectively zero. A visual field of Vantablack, the color hash 000000000 given cosmic expression. If you were lost here, with no means of propulsion or navigation, you would be stranded for eternity. The concept of forever takes on a new, crushing weight. Given the expansion of the universe, even if you were motionless, the space around you is stretching. The nearest galaxy is not only millions of light years away, but that distance is increasing every second. You are not just stranded on a raft in a static ocean. The ocean itself is growing, pushing all shores farther away. It would be just you, your thoughts, and the encompassing nothing. Madness would likely be a swift visitor, as the human mind is not engineered for such profound sensory deprivation and existential isolation. Yet, in a perverse way, there might be a terrifying peace to it. No threats, no noise, no demands, no gravity to fight. Just an infinite quiet drift in the greatest nothing the universe has to offer. You would become a monument to solitude, a biological time capsule adrift in a sea of oblivion. Your body, protected by its suit, would not decompose, it would simply persist. For billions of years, it would coast through the void, a frozen sculpture of a once living being, untouched by wind, rain, or any other force of nature. It might be the most perfectly preserved artifact in the entire cosmos, yet there would be no one and nothing to ever find it. And so, there you have it. Nothing to see, literally. One might ponder why we choose to contemplate such a desolate, featureless destination when the cosmos offers such splendors. Our own solar system, a mere 2 light-years in diameter if we consider the outer reach of the Oort cloud, that spherical shell of icy planetesimals, remains largely unexplored. We have sent robotic emissaries to the rust-colored plains of Mars and the corrosive, crushing hell of Venus, but human feet have touched only our moon 250,000 miles away. The icy majesty of Pluto, that distant dwarf planet, has been glimpsed by a single speeding spacecraft, New Horizons, which revealed a world of startling complexity, nitrogen glaciers, water ice mountains, and a vast, heart-shaped plain. Venus alone presents a surface so lethal. With atmospheric pressures 92 times Earth's, hot enough to melt lead, and clouds of sulfuric acid that a human would perish in moments. There are so many wonders closer to home, full of light and form and drama, the raging storms of Jupiter, the icy geysers of Enceladus, the methane lakes of Titan. The universe, it seems, is brimming with spectacle. Why turn our gaze to the absence of spectacle? Yet, the void calls to us. It is the counterpoint to everything we know and are. We are creatures of light, of matter, of connection. Our biology is a frantic dance of chemical reactions. Our societies a complex web of interactions. Our planet a dynamic system of ceaseless change. The void is the absence of all three. To contemplate, it is to stare into the mirror opposite of our own existence. It forces us to recognize that the universe is not made for us. It is largely empty, cold, and dark. Our vibrant, noisy, crowded planet is the anomaly. In the grand narrative of cosmology, we inhabit a vanishingly small speck of condensation in the thin walls of the cosmic foam. The void is the overwhelming reality. It is the backdrop against which our fleeting drama is played out. To understand the void is to understand our true place in the cosmos, unimaginably rare, precious, and isolated. Your journey to the Bootes void, this thought experiment of falling into the great nothing, is ultimately a journey to the edges of human comprehension and the frontiers of cosmic reality. It is a reminder that sometimes, to see the true shape of things, we must have the courage to look not at the light, but into the darkness between the lights. To find meaning not only in the presence of stars, but in the majestic, terrifying, and beautiful absences that hold them apart. And as you float there, in that perfect perpetual night, a single small thought against the infinite quiet, you might finally understand the universe is not a story of constant brilliance. It is a story of contrasts, of brief, fierce illuminations against an eternal dark. The voids are not mistakes, or voids in the sense of lack. They are the fundamental ground state, the canvas. We are the fleeting brushstrokes. In the grand chronology, the age of stars will pass. In trillions of years, the last stars will fade, their nuclear furnaces cold. Galaxies will evaporate as their stars are flung away by interactions or consumed by black holes. Those black holes will themselves slowly evaporate via Hawking radiation, dissolving into faint puffs of particles. The universe will become a colder, darker, emptier place, approaching a state not unlike the interior of the Boat's void, but everywhere. The void is not just a place, it is a prophecy. It is the eventual fate of all things, a return to a near-perfect equilibrium of nothingness, the heat-death of the universe. In that light, our journey to the void is a journey to the end of time, a preview of the cosmos's final act. So when you next look up at the night sky, find that arc to Arcturus, and let your gaze settle on the blank space beyond. Know that you are looking into a realm of profound absence, a cosmic desert of staggering scale. But also know this, that very emptiness is what makes the light possible. The void is the stage that allows the drama of galaxies to unfold. The separation it provides is what allows complexity to arise, for islands of order to persist against the entropic tide. We are children of the light, yes, but we are also children of the void. We exist in the delicate balance between the two, in the narrow zone where gravity has pulled together just enough matter to ignite stars and forge planets, but not so much as to collapse into oblivion. We are the music that exists because of the silence between the notes. The void is not our enemy. It is our context. It is the quiet against which our noise has meaning. It is the dark against which our light shines. To fear it is to misunderstand our place. To ignore it is to miss the fundamental character of our universe. We must, with clear eyes and steady breath, contemplate the great nothing. For in doing so, we finally see the something that we are, and how truly remarkable it is that we are here at all, in this fleeting moment between the void and the void. And as you float there, in that perfect, perpetual night, a single small thought against the infinite quiet, you might finally understand. The universe is mostly good night.